Muito bem. Pronto, em primeiro lugar, obrigado por terem vindo aqui. Nós também, houve pessoas que pediram, estamos a fazer streaming, suponho que já estará online. Portanto, é com grande prazer. Temos aqui connosco o engenheiro Marco António Silva, formado nesta casa há uns anos atrás, que é Senior Solution Engineer na Microsoft, pela área EMEA, não é? Europe mesmo, que é digamos, um grande evangelista e também praticante nestes tópicos que estão na moda. Pronto, tem a ver com AI, Agentic AI e tecnologias Microsoft, não só do ponto de vista de engenharia de software, mas também de outros tipos de utilizações, como docentes, etc. E, portanto, a ideia é fazer uma pequena apresentação, mas essencialmente tentar ter aqui uma discussão. Depois, grande parte do tempo, o ideal é termos aqui alguma discussão de questões. Portanto, Marco, muito obrigado. Está bem?
Ora essa, pessoal, muito obrigado e muito obrigado a todos por me receberem. É um gosto enorme estar aqui, voltar a uma casa que me recebeu durante muitos anos. Estive aqui com muito prazer e pronto, mudei-me para Lisboa e é sempre bom voltar cá em cima e voltar a verdade é que estou mais perto de Lisboa, falo muitas vezes em universidades em Lisboa, não consigo vir tantas vezes cá em cima, mas faço sempre que vocês quiserem, com muito gosto. O desafio para o qual lançou-me e que eu tenho todo o gosto de estar aqui a falar hoje convosco era mesmo falarmos sobre Agentic AI e nas diferentes dimensões. Eu não tenho... estamos a fazer isto em português, hoje de manhã estava a falar a algumas pessoas em inglês, não há ninguém que não fale português. No one is like wondering why am I speaking in Portuguese. More or less? You understand it? If there's no opposition, I'll do it in English, and that's not a problem. But it's okay for me. English? Okay, no worries. So coming back to English, like I was saying, thank you very much for inviting me and for having me. For those of you that don't know me, Marco Antonio Silva, Pascoal was saying, so I'm a senior solution engineer now, recently moved to the EMEA region. So I work for Europe, Middle East, and Africa. So it's basically this chunk of the globe. You cut it, and that's my turf now. So I work in a team called GBBs, called Global Black Belts. We are a team of engineers that we're around 100 in the entire world, and we're specialized in some technologies, typically incubating projects, new technologies and customers, giving feedback from the field directly to the engineering teams. And I'm focused on one chunk of our solutions called Migrate and Modernize. So modernization of cloud-native applications, cloud-native technologies using artificial intelligence. So tools that can improve the way you build code, change code, modernize code, and kill all the legacy that exists on our customers. So that's my mission. So I'll be talking to you about agents, and you can imagine that most of the technologies that you use to modernize applications are agents and all the agent framework. I'm a developer at heart. I still today develop every day. So I'm an architect. My path was from consultancy, engineer, solution architect, enterprise architect, digital advisor. So I did all the path of architecture, and today most of my work as a senior engineer is to architect systems and solve problems. Okay, so opening up the discussion. We have two microphones, and we can just share. Make this a conversation more. I don't have a lot of. Okay, I can have a lot of slides. I can just do it slideware all the way. I have demos if need be. So I didn't prepare a hard-coded session because depending on your questions, we take it everywhere we want. Okay, so let's move to where this agentic. Oh, here we go. Let's move to where this agentic AI stuff really matters. So one of the things I was doing this morning with some students, and we were talking about agents, is the definition of an agent. I remember when I was sitting here studying, we were already talking about agents and artificial intelligence at the time, and it was a different concept because technology was a little bit different. So the way that I put this to my students today and to my customers is an agent has to have three main things. It could be more than this, but it has to have three main things. At this core, this new definition of an agent, and any agent that you may be using, has to have the ability that comes from the LLMs or SLMs that you're using of reasoning. I hate the word, by the way. And it's been recorded, so it's not a word that I love, because human reasoning and artificial reasoning at the moment are very different things. We as humans have the ability to think about how to solve a problem, and you can explain it as well, but you could explain something that you don't understand. It's possible for you to mimic an explanation of someone else, looks like you know something, but you didn't reason, you didn't go through this process. So these agents have the ability to pick up a problem and mimic what a human would do for reasoning, basically decompose the problem into smaller tasks and then have a plan to address that larger problem that you're addressing. Either way, it's either you're having the agent real reason or artificial reason that we have. The reason is imperative for you to have what is now called an AI agent or any of these agents. So reasoning is the first step. Even if I don't like the word, well, it's the only word that I have, and it's fair. It's a fair assumption of comparison at the moment. The other thing that you need, the agent needs to have a mission, needs to be grounded to something that it does. Needs to have a role. These have basically what we call an instruction set. What is your role? What is your mission? What will you do? What are the grounding parts that you want to give him? So you are a developer and you develop in this language following these principles, because otherwise it's open. And you know what happens? Because you're using all the same LLM, it will hallucinate really easily and go on his way, far away from where you want it to go, and because you didn't ground it, that's not a good agent. So you need the instruction set, you need the role, you need the grounding, so that's one part. And then the third and most important part, I think, that differentiates all of this, well, to be honest, the most important part is the reasoning, because that's the biggest thing that came out. But the second thing is tools. So it needs to have a set of tools. An agent without tools is a chatbot, okay? It can answer questions, but it can only answer what the model does. No. Other than that, it will have no tools, neither to retrieve new information, neither to perform any actions, or even, because it will not have a way for it to store structured information from your conversation that it can then use with the tools to retrieve and store and retrieve and then change states and stuff like that. So to be a real agent, you need to have, you can have tools that don't perform actions, only retrieve information, and that's a valid agent. But you will have tools to retrieve additional information from the model, because otherwise it's, well, you go in ChatGPT, here you have your agent. But you don't call it an agent, you never called it an agent. It doesn't reason, doesn't act, and doesn't retrieve anything. Well, there are agents inside it that you could do in the newer versions. But if you go into the GPT model direct, the GPT itself, the LLM, doesn't have that. You build it around it, okay? So those are the main elements that you need to build to have an agent. And if you think about how we are doing this, Microsoft is building their agents. We are using a framework that I based my workshop today on that framework, but there's more than that. You can build it pro code. This was the framework that I was demoing today for the group of students that I was with this morning. We moved it to a new framework. We had many of them. Now it was in last October, this October. We launched a framework called Microsoft Agent Framework, MAF. So Microsoft Agent Framework is where the unification of many of the other frameworks, semantic kernel, we had AutoGen as well, some SDKs for Copilot and stuff like that. So we merged it all together and put it in one framework. So that's MAF, okay? So if you're going pro code, if you want to build your own agents, that's one way for you to do it. You build all those dependencies using an SDK called Microsoft Agent Framework, and you will connect to any LLM, local, any SLM as well, any model that, well, you need one model that has ability to reason. So if you pick up another chat completion model that doesn't have it, it won't work, but it can work on a deployment on Azure, on OpenAI, or wherever, on a container right next to it. And you can use Phi3, for instance, to use that to deploy a SLM locally, for instance. That would work. Again, you could have databases, repositories, connections to storage, all of them in Azure or anywhere else. You can have a Redis cache as well, connect to whatever pieces of technology, build your own architecture on the Microsoft stack, outside the Microsoft stack, so using the Microsoft Agent Framework. But that Agent Framework will integrate into the other technology. So if you want to build a pro code agent that you want to deploy later for students to use or for in your enterprise to use in a Copilot or stuff like that, but you need control, then that's the framework. The other way that you can do is use Copilot Studio. So that's a low-code approach for you to build your agent inside M365. And that's, you don't need code, just you use the connectors, but you will not have the ability, like any of the frameworks for low-code, that, especially the ones that for building agents, you'll be locked in to the connectors that exist and to the deployment model that exists. So you will only deploy it either on Azure AI Foundry, or you will deploy it on M365, on Copilot, okay? And you can even use only Markdown. So you can build agents for your I don't know if you know this, but it was released recently with the Copilot for GitHub Copilot. You can build agents just by using Markdown. So you create a structured Markdown. I can show you guys. I'm involved in the project where we're building that as an open source project. So everybody can use more models, more agents like project manager. I was showing Pasquale just a couple of hours ago, just sharing that. And this is another way for doing it. So we are using these frameworks. We are using this approach for our own products. So Microsoft Copilot, the M365 Copilot that you're using in Teams, so that's built on these frameworks and using this. So that's why it's extensible for that. We're using it on GitHub as well for both the practices and the framework. Xbox also has a Copilot. You can imagine, built on this. So we have, in Microsoft, we have a saying, it was coined by Microsoft, I didn't know this, but it's the place where I hear it the most, is eat your own dog food. So we eat our own dog food. We build the products, but we use the products. So in this way, so we say, oh, this framework is very cool, but then you go in, how are you building M365 Copilot? Oh, we're using another framework. We're using LangChain on this one. Oh, okay. So, but I don't use LangChain. I use your, oh yes, that's our recommendation. No. We eat our own dog food. Most of our product teams are customers of other product teams. So that's how we build it. So what you are seeing in terms of agents being built is this. And we are building versions of the Copilot agent, for instance, the researcher, the analyst, all of those versions are also being built using these type of integrations. So, and as a summary, and maybe we can leave this open for your questions, about the ecosystem, it's this one here. Okay, so if you think about this as an ecosystem, we have Azure AI Foundry, is basically the one-stop shop for everything that is AI-related, both MEL, but also LLM, so Gen AI. And inside there, we released agent catalog that you can release your agents or publish your agents there. You don't need to publish them there, but you can collect agents from there, you can publish them there using the Microsoft Agent Framework. So if you're really keen in building your custom version, like really you have a hard problem that is not solvable with just connecting stuff, a bunch of instruction sets and putting that. So then Agent Framework is in the middle, and you can use it to publish both the SDK for M365, for Agent Framework generically, and just build a container and run it, or publish it on the Agent Catalog. And then we have another thing that's very cool, is Agent Service. So when you really want to have your agent runtime needs to run somewhere, so your code needs to run somewhere, you can put it on the agent service instead of running it on a container. You will put it there. You will built in, no questions asked. You don't need to do anything. Have management of multiple threads. So You know, when you create a new chat on your agent or in Copilot or whatever, that thread, so you have persistent multiple threads built in. You have long-term and short-term memory that you can access, and it's managed by it. So, and then you can connect to your own data sources. So you have a bunch of documents in PDF on a data lake. Connect there. The data lake isn't in Azure. It's on a file share. Okay, connect to the file share. It just needs access. The file share is accessible through a private link or a public link. Yes, done. Do it. You will connect. But if you're using connectors from Azure, also the same. To be honest, I don't think it's easier or harder to go inside Microsoft stack or outside the Microsoft stack for this framework. Honestly, I don't. I connect to Redis Cache as easy as I connect to Azure Redis Cache. To be honest, it's the same endpoint, same API, it's the same thing. It's the same connector, same NuGet package, same thing. So it's not a problem for me. And then you get all the cool stuff built in. MCP servers. Does everybody know what the MCP server is? Who doesn't know what an MCP server is? Okay, so you don't know. Okay, Model Context Protocol. Anthropic launched this way for you to expose your tools, your APIs as tools for your agent to learn how to use those tools. Remember the three things? One of the things is a tool. So that tool can be an MCP, it can be not your code, could be an external service that you want to browse the web and you want to use Bing, for instance, or Google to access the web. So you want to, your Bing API could be a tool. And now your agent can search the web for an image instead of you having to code it yourself. There's an MCP server you can use and just use that. Or you want to connect to GitHub to create an issue and you want your agent to go and create the issue as part of the tools that he wants. So there's an MCP server, Model Context Protocol server from GitHub that GitHub's manage, and you just put that, you don't need to add anything. Your agent will learn all of that. So all of these capabilities come built into this framework. So either you're using Procode, MCP servers, imagine, low-code approach, connect an MCP server, also easy, deployable. So basically, this is the universe that exists in terms of frameworks, tools that you could use to achieve many of these goals. I imagine there may be a lot of questions, either for the technology, for the applications on this. So I have demos, I have everything. So maybe we can open up the floor for discussion. Any questions, any challenges that you guys want to approach? Let's open this discussion up. Yeah, go for it. I'll try to move around and share this microphone so that people at home can also hear the question. Go for it.
So before you were saying that it's possible using Microsoft Copilot and a Markdown file to then create an agentic framework out of an agentic flow out of that.
Mm-hmm.
How
do you want to see it?
Yeah.
Okay. So I'm not going to pick up the mic because maybe you're going to. Oh yeah, press the button. Good. So maybe you're gonna have additional questions. So let me show you. So one of the repos, and I think you guys are gonna enjoy this one. Let me just come here to my repo. So I'll share the link so that you guys can also come here and see. Here we go. No, that's done. Wait a second, and is spec. So I've been working with some colleagues of mine in this open source repo called Spec to Cloud. Okay, Spec to Cloud is from wait, there you go. So EMEA app GBB, so that's my team, and inside our org we have Spec to Cloud. Spec to Cloud is it's an open source project that we're building, and the goal for this is to build. You have a quick start here. It's really easy for you to deploy. It's built on GitHub Copilot. Okay, it's built on top of GitHub Copilot, and you can use this as a template. And you can create a new repo for if you're going into a greenfield approach, you want to build a new app, but you want to go full-on agentic mode to build it or to manage, or you want to go brownfield and you have already some code that you want to spec out and then insert an agent into it. So if you use this project, this basically is an accelerator for you not to build your own agent. So we're building the agents for you. And it's open source, so you can change the way that the agent is done. So I'm going to show you how this works. So there's the .github folder. For those of you that, everybody's familiar with GitHub. So the .github folder is a reserved folder that you can put stuff there that GitHub understands. So there's a folder structure and everything. So GitHub extended this capabilities for these folders, okay? Let me just, so, here we go. So you have agents folder, prompts folder, and workflow folder. An agent folder, inside the agent folder, you can build this, these MD files, okay? And each of them is a .agent, okay? So .agent.md says name of the agent, .agent.md is the naming convention. This is basically a standard based on naming conventions, structure folders and naming conventions. And you have an architect agent, for instance. And the architect agent, if you go here, let me just take this out of the way. So if you see, it's a markdown, typical markdown. I have a bunch of labels and everything, so I'm just going to go and show you guys in raw form the file. So you add things like, this agent has access to these tools. These are the MCP points that you want the agent to use. So he will be able to use these tools. You say which model you want the agent to run. Remember that you can change models in GitHub. So you put this, and you have a handoff. So the label for create ADR, so /ADR, if the user /ADR this, the architect will hand over this file, the ADR.prompt. MD, okay, and the generate agents MD. So this is the generate agents is the step that you can put in your project that will precompile your agents to the agents MD file that it needs. So it will be basically the prompt is /generate MD.prompt that I have in the prompts folder. Okay, so I can create a workflow that the agent will understand. This will be automatically configured without any code. This is just tagging this in YAML. Beautiful. I think this is so elegant. And then it ends here the configuration. So the thing that you can build your agents is, imagine what? Text, MD. So your responsibility as an architect is, 1, architecture decision recordings in ADRs. Create a main ADR that documents key architecture decision. Location, spec/ADR. So we will put the file where I told them to put it. So this is grounding in text. And when you run this agent, you will basically do what is told to do. Is responsibility, is instruction set. And this instruction set is long. Okay? He will load this, and you have one agent. More than one agent. Imagine now that you want your project, so I don't want to explain how to build an FDR, a function definition, okay, and requirements. I don't want it to do this. So I have many other agents here, the tech analyst agents, all of them have multiple responsibilities, but I also, to accelerate this, I can have prompts. For instance, I can have a prompt called frd/prompt, .prompt.md. So a prompt.md is exactly what you expect it to be. It's a prompt already built. So the agent that will run this prompt, the target of this prompt is the PM agent that is on the folder, the other folder. So if I do /frd and then type some text, you know when you're using GitHub Copilot do /fix /explain, you know what it is? It's a prompt. It's basically this. It's already pre-built. So you're using this same framework, this same structure to build your own /something, and you point it towards an agent, one of your agents if need be, or Copilot itself. And you will do /fix, and there's the context, and that context plus this prompt will be sent to the Copilot agent, and it's done. So this is how you build a really large workflow, dependence, hands-off, and everything, of multiple agents to solve large, complex problems. This structure here, if you use it, you will build you the entire application, function requirements, everything. So we build this as a workflow so that anyone can build code on any language through any process that they want. And it's already done in a very generic way. And if I can show you guys, I think I have it in the diagram as well already. We're just this morning we were doing the demos in Portugal, saying, "Oh, I saw some pings on this. This is an active project. I'm coding this and testing this every day. This is one of the main active projects that I'm doing now." And as you can see, so the user can have this high-level description. It does /prd, and then the PM agent creates a project requirement document. So we will create an MD file, put it there. And then that /FRD now breaks this down into feature requirements documents. So it will then start splitting that into tasks. And then the dev lead will read the standards that you have and generate agents.md so to build all of that, and then finally do the plan, technical breakdown of all the tasks, and then you can choose. You can delegate or you can implement, and if you delegate, it creates issues on GitHub, and then you can use Copilot to do, or you can develop locally, and you say /implement, and then the dev agent will start implementing that in that branch, okay? And then finally you do the deploy and it's done. So, and if you want, there's the reverse engineering one. You can reverse engineer from the application, create basically from the code without changing any code. It's completely grounded. You cannot touch anything of source, but you can build your FRDs and then you will basically create all the requirements documents. You will also generate architecture documents, best practices that were there, and document all of that. And then with that all done, you can /modernize, and then we'll run the prompt that will, okay, now let's evaluate vulnerabilities and why you need to modernize this code base, what should change, plan those tasks, and then the dev lead that was implementing now comes in and starts implementing the changes. But the dev lead can change. None of the other analysts can change. So this is how you build it. This, to be honest, quite simple. It gives a lot of work to ground him, but that's the new, I think the new type of spec-based development that we need to think about is we're not so much coding, more defining guidelines and grounding these agents that do the heavy lifting of coding. It's the same thing as a car. You could take your sofa and move it to the other place on your back. It will hurt your back. There's these other services and trucks and everything that can do that for you more efficiently. So this is the service that does the heavy lifting of moving your house, and you just go there and you point it the right direction and make it your own, but don't do the heavy lifting. That's my opinion. It's a great question. Did I manage to answer? Okay, good. Thank you. Any follow-ups, guys? Yeah. Yep. So just a microphone for the people that listening remotely can know.
Oh, yeah. Okay.
Okay.
So thank you. I saw something similar to this, I believe.
Okay.
In OutSystems.
Okay.
And LangGraph.
In LangGraph, correct.
Okay. Could you please have a comparison?
Yes, sure. Okay. So this what I showed you here is it's midway between a low-code approach where you would just drag and drop your workflow like the agent. Correct. So the correspondency would be Copilot Studio. Okay, so Copilot Studio would be the same thing as you would do in OutSystems. So low code, you have all the connectors. You want to connect to a database. You want to connect to your index. For instance, you have indexed your documents, and you just have a vector index, and you use that. So for all of those, that stack is what we call low-code approach, and low-code is Copilot Studio. And Copilot Studio, you could simply deploy it. It's in the platform. It's in M365. You can deploy it for yourself, for your team. You can deploy it on Teams itself, and it would appear there as another agent, like analyst or researcher appears on Teams. And that is like when we are doing the same thing as OutSystems, to be honest. It's a low-code approach that we can build Power Apps like OutSystems does with Power Apps. So that would be the correspondency. But think about this as the agent part of low-code. So Copilot Studio is the agent builder of Power Apps. So instead of an app, you get an agent. And you can publish it in your enterprise. It's completely closed down. Okay, so your data, the endpoints that you're using, if you're using private endpoints, they will stay private. So and it can connect to your own enterprise identity as well. So if you're everything that has to do with authentication, it's built into the platform through M365. So your organization already has M365. Therefore, they will all be able to basically connect to it, and it solves this one thing that's very cool that it solves out of the box. You know, when you have your own personal documents and you're using, for instance, Copilot, and you say, I use this to prepare my one-on-ones. Search my entire my chats and emails for feedback from customers. Structure it into, I have to do a thing called Connect. Structure that for my Connect so that I can share with my manager. And it goes through my stuff, doesn't go through anyone else's stuff, goes through my emails, gets everything, because it has ACL built in. So when you're using the Copilot Studio, you have all of that built in, like you do on any other part of M365 with that identity. So that's basically it for low code. The LangGraph is pro code. So LangGraph and LangChain is basically a framework where you build your workflow and it's pro code. The correspondency with that would be the MAF, the Microsoft Agent Framework. So Microsoft Agent Framework has the ability for you to build orchestrations, okay? Like graphs, basically. So you would build, and it's the way that we work the orchestration, like LangGraph works, is like a graph. So the names are the same. So nodes and edges. So you create a node and an edge, and you create hands-off from one to another. I can show you that in code. It's really simple. So the way that you build it is you, like we were doing on that agent, so this agent now hands off to another. I was doing that in MD, and because that's like I said, it's mid-bit between pro code and low code. So I'm writing the definition. I'm not writing code, but I'm configuring it. I can imagine that for a non-developer, that's too much. So Copilot Studio for them. For an engineer, I could imagine this between either I want to do some code because I want more control, or I'm good with just defining the structure and using the model and using this file configuration. So that would be the agent.md format that Copilot and GitHub launched. So for this, I can show you guys in a minute how this looks for the correspondency in LangGraph. I can go to this one. I think this is too much. Is this size okay? Okay, good. Okay, so I can show you guys workflows built, for instance, in concurrency. So the way that you do is basically this. So you have a workflow builder. This is part of the MAF, so Microsoft Agent Framework. So it has a workflow builder. You set the start executor, and then basically this is the starting point. And then you add fan out edges, fan in edges from that execution to, I have two agents, the physician and the chemist built in. And so basically they go in and out. So nodes, in this case, is a concurrency. So they go to the physicist and to the chemist to solve a problem either by chemistry or by physics, and they will look at the problem on their own scope and then give me the two answers from the physics perspective and from the chemistry perspective to solve the same problem. And the way that this does, basically, I'm creating the two agents and then building a workflow that starts like an orchestrator that's spreads out. So I can have hands-off, Agentic. I can have all the workflows that you would build in LangChain or LangGraph. Chain would be a little bit different. The one that does exactly. The Agentic would be in LangGraph. If it was sequential, it would be more of a LangChain. But so the difference between these two frameworks, in my opinion. I did a podcast with Sean. Sean is the PM for the program manager for, at the time, was the PM for semantic kernel that now evolved into what is today MAF. And we were discussing exactly that. So semantic kernel at the time and now MAF is the enterprise-grade solution for you to build these things. In my opinion, the biggest reason for you to go into this agent mode. So if you're doing research, anything goes, right? So if you're exploring, when I was the director for innovation in Portugal before moving to EMEA, and when I was the national innovation officer, everything goes. Innovation is, there's no limits. So every technology that makes sense for you to try, you should try it. When you're going to an enterprise-grade solution, either for that you want to distribute for students or inside an enterprise, you need to think longevity, stability of the framework. How will you upgrade this? Are there many breaking changes through time? And well, if you're using LangGraph for a while, you already had many breaking changes, like hard breaking changes, like I want to die and go and like in the corner cry for this latest update because I see that I'm going to spend a week just to put it into the new version. This framework doesn't do that. It's mostly, and the way that we do these frameworks, because we've been building frameworks for .NET framework, for instance, I can upgrade code from framework to core easily. There are really low breaking changes. We're talking about the team that's been building for the since .NET 1, 25, 30 years, stable. So this is the same guys that are building this framework. So it's more stable, it's more enterprise grade. For instance, it is not easy for you to connect OpenTelemetry to LangChain. It's not easy. You can build your own, so you code your protocol. Everything is buildable, guys. We're engineers, we're in engineering school. Everything is buildable. There's no impossibles. There's just more work, less work. But if you think about it, if I'm selecting as an architect, like I said, most of my years have been as an architect. If I select a solution to solve me a problem, I want those features to be built in and stable. So observability, built in. Tracing, everything, hotel, built in. Authentication, I want to connect open authentication protocols. Any IDP that uses OAuth is there, because well, our IDP is open authentication, so it's expected. So when you're thinking about those hard problems to solve in an enterprise, should be easy to solve in an enterprise-grade solution. So the difference between all of those other frameworks and this one is this was built to be enterprise-ready. The problem sometimes is, oh, I want, it's cooler if I do this way. If it's not stable enough, then it's probably not built into the framework, okay? Because that would create breaking changes easily. So sometimes you may see some things that are missing and you need to hard code some edge stuff. But still, I've been building some agents for a while now. I started with the previous version with semantic kernel, and to be honest, it's very stable. Yeah. Okay. You send me another one from another other. Okay. Okay. So hopefully I answered that question as well. The concepts are the same. Yes. You have more enterprise features, but on top of the same concepts. Hopefully, yes. I'm happy with that feedback. Thank you. Any additional questions?
Yeah, perhaps I could take the privilege of making a question. Not so technical, because I also don't know exactly, we have people with different backgrounds. But one question that arrived by email is, in fact, it's more about LLMs. When the problem of privacy, so solutions for ensuring privacy when we are using, namely in our educational context. So what kind of solutions, because one thing is to use those commercial solutions out there and cannot send sensitive data to cloud.
Yep.
But do we need to use locally deployed models like open source models? Or what kind of solutions on the cloud can ensure the privacy? Yeah, that's
a great question. To be honest, one of the things that
not so much about agents, but LLMs.
No, it's yes, exactly. That was where I'm going to start. It's not so much as about agents themselves as how to use LLMs. One of the things that I do with my students back in Lisbon is one of the first classes I go there and I try to tell them it's not that they should be afraid, but it's like, okay, how an LLM is trained and how all of this is being done. So everything that's free normally means you are the product. That's one of the catchphrase. If you want. Tá à vontade, assim eu vou responder. So, when you're going into these open source models that you don't deploy or go into the general OpenAI APIs and other APIs, so if you read through the long terms and conditions that you have there, those things are, you're collecting all of the data, okay? And it makes sense, okay? So the next generation of AI is being built by the use of this AI. The way that Microsoft is done, we don't have our own, well, we have some of our own models, especially SLM. So FHI is one of our models. So in that sense, we build also some AI, but we're not into building AI models, larger language models business. We're into integrating everything and making it easy for everybody to use. So that's why when you go into Azure and you deploy Foundry, so Foundry that I was showing you guys is the one-stop shop for every model. So there's, the last time that I was looking, it was like 25 or 28,000 models there. Everything in Hugging Face you can deploy on Azure, almost anything. So we're updating it frequently. You can deploy Grok, you can deploy Llama, you can deploy many models. Every time that you deploy it in Azure, it's on your tenant. Logging of that model, it uses the same infrastructure that GPT is using. So you don't see any difference in the core part of the model, but you have a lot of the enterprise features around it, meaning logging is only in your tenant. Same thing as goes for your logging of Office 365. So when you're using Office 365 in your company, you probably have secrets that are IP driven for you. And that should stay private. And in that sense, that's what it is. It's private. It's on your tenant. You control it. Microsoft. I don't know if you guys know this, but if you open a ticket, if you open a ticket at Microsoft and you ask for help, and they say, "Oh, I need to access your virtual machine," the reason why the support engineer is saying that because it can't. There's no way for it. It's encrypted. It can't. You need to either give access yourself like you would do anyone else, because it cannot look at the logs. It can only look on the logs on the server side from the infrastructure. The infrastructure is anonymized, so the problem that you're having probably is on your logs, so you will need access to your logs, so you give them. So in that sense, privacy is guaranteed on any other product, including the LLMs. So when you're going to Foundry deploy a GPT-4o model, that 4o model has its own endpoint, your endpoint. And everything that goes through there will never land on any of the training sets of OpenAI. It's completely private. And same goes for Llama, same goes for Grok, same goes for everything. And especially in the EU, I think this makes a lot of sense. We have this, well, we have the AI Act, we have all of this regulation that we need to make AI safe. So when you deploy it, and this is something that some of you could say, okay, this could be a problem or a limitation. Because it's enterprise grade, the safety guards are built in. You can bypass them by opening a ticket and asking for which bypass do you want to do for which part. It needs to be approved, and you need to have a business certification for that. Meaning, if you want to do harm, you will not be able to basically bypass, because the justification that you have will not be valid, and you're not going to pass for that. So safeguards are also built in for all of the things that you deploy on Foundry. So the one-stop shop for that is Foundry, deploy there, and using these SDKs, connecting to models that are deployed on Azure through these principles will get you that built in. If you don't, then you're responsible. In this case, basically, you can put Microsoft responsibility on the table and say, my provider provides me this service, safety, anonymity, so privacy, everything is provided by default by Microsoft. And legally, you can say, if you're at fault by not implementing this, then you're not. You can point, and the Act is very clear on this. Either you can prove that you're following the rules, or that you're using technology that follows the rules, that is certified. And if that's the case, then you're not legally at fault, and then Microsoft is at fault. So you can make sure that Microsoft will not be at fault. We're very good at not being at fault of those things. Make sure that we comply, and we're all the things are to the book. So that's my take on privacy, is that you can use the open source deployments and everything directly on your machine, but you're taking on the responsibility. If you use it on Foundry, you don't even need to care about this. It's just one click, deploy. I can show you guys, it's really easy. You can select from one of the models and it's done. And you get all of that built in.
With some cost, I think.
But you get the cost either
anyway,
way.
it's equivalent. Yeah, it's equivalent.
So either you using your own infrastructure and pay for the cost, you deploying, you can say, okay, maybe it's, to be honest, tokens are very cheap on any cloud provider. So we're not more expensive than OpenAI. I can tell you that by heart. We're not more expensive than OpenAI. So the privacy that you get, the goal that you get for like what 4% more of the infrastructure, it doesn't make sense to go through the risk and not do that.
Hello, thank you. I'm a little bit shy of making a question because I'm a non-coder, but I have been trying to learn Python to develop in AI. So
you're in a good path.
I'm a user. I'm chemical engineer, old, and so I'm a user in a user.
So you're not a developer. You're more using AI as an end user.
But I'm trying to understand it quite deeply to use it correctly.
That's good.
So I hope my question won't be out of subject.
That
being said, first of all, in this example, we see the chemist, me, and the physicist. And my question is, what is the underlying L model that is in the background to answer? Is it necessarily an LLM or not necessarily? So what are the sub-agents, if I may tell it like this?
Okay.
And another question is, I have been following some YouTubers and in that stuff, and I read, well, I listened to a claim that conversations between agents would degrade as long as they develop, and the smaller LLM will take advantage over the biggest ones, because the biggest ones, and that's now an explanation, will always say yes, will always be very complying with the user, and the smaller will probably give a path that is not the best. And I would like to hear your opinion on that. Thank you very much.
Thank you for your questions. So I'll start with the second one, and then I'll explain this example that I hope answers the first question. So the second question is very on point. We're being using. I was telling you, an agent has to have reasoning capabilities, and an LLM is way more. Large language model is way more than just reasoning, okay? It answers your questions, has a huge database of knowledge. Well, it doesn't have the knowledge, it has the probability distribution of tokens that then represent knowledge, just to be fair. I'm in the university, so I should be precise in what I'm saying. Doesn't know anything. But that model is very expensive to run. Talking about money and power, ecological impact, training, all of that. It's really expensive. And what I want is it to focus on 10 tools. I don't even want the knowledge that it has. I don't need it to answer the question of the chemists. I want it to turn on the lights and decide and do my domotics at home. Why does it need to learn Shakespeare to do that? It doesn't need that, but it's there. So when they activate it and ignored. It's in the net. It's in the deep neural network that's there. So small language models, SLMs, can have the basic understanding of language, so that it understands, turn on the lights, it's too cold, complex tasks as in prepare my morning for me, and you understand what that is. You can understand this, have the tools, and not have this huge amount of training, expensive. It can run locally even, if need be. It can run on my phone. It can have offline support with this. I can never run an LLM on my phone. It's not going to happen. Well, maybe a couple of years from now, the GPUs will be on the phone, but it's going to be really hot on my pocket, to be honest. I don't know if I want that. I have seat warmers in my car. I don't need my phone to be a seat warmer. So that's the thing. You don't. The future of agentic AI will be multi-agent, multi-model. Okay. For some agents, will make sense to be able to go into an LLM. For some agents, for some parts of the tasks, it will be an SLM. And maybe it's not one SLM or one LLM, it's multiple. Some LLMs will be better at generating code, some will be better at generating documentation. And because I was telling you guys 20, 28, 20, 30, 40, I don't know what's the number now in Hugging Face, of language models that exist. 1,000 models, 28,000 models, 30,000 models that exist on Hugging Face. They are not all bad. There's not one that, they're all good at doing something. And context-specific tasks is the way to build agentic AI. So you will have smaller, larger, different models doing different tasks. So maybe the best agent to answer questions about chemistry will be a university agent that we did it here at FIP. And maybe for the chemist one is one in Harvard, and that's the one that should be used or better for at doing the task. And when you're building agent, you should be, like any architect and like any engineer, select the best tool to achieve that goal. So what I think will be, and what I truly, utterly believe, will be the future will going to be for the planning part and deciding for the reasoning, it will probably be a SLM, more focus in tasks, and then you're going to have multiple SLMs going out, very good at doing planning for different types of logic problems, and then you need to figure out your agent should be planning, or orchestrator or whatever should be planning on this task or that type of task and selecting that. And then you can have large language models to solve larger problems that require knowledge. So answering questions, understanding code, generating code, for instance. I don't want to have an SLM that is very good at generating code. I want it to really know a lot of code, unless I only want an agent that understands like COBOL. Maybe there's not a lot of COBOL to understand, and maybe an SLM can solve that problem, okay? So depending on the problem, still, an SLM could be a good solution. So hopefully I got to the point that you were asking on the second question. For the first question, you were asking how, so what's the underlying way this demo works? I didn't go into detail, that's why your question is completely pertinent. So the way that this does, and I didn't explain how this works, and I'm gonna do it in 2 or 3 minutes. So the framework itself uses a client. So remember that I told you guys, this is Procode, and you said that you started Python, right? I don't have this demo in Python for this one in particular, but I have others in Python, but not this one. But you're going to learn C# and maybe love C# after this one. I hope I love C#. So in this case, you have a client. So this client here is an Azure OpenAI client. I could use a Llama client. In this case, I'll be connecting to Llama. Doesn't matter what the LLM is. You will use the client that matches the LLM that you want to connect. But after that, this is basically how I connect to my endpoint. And with that, I create a chat client, because I'm creating a chat interface in this demo. So my interface is through text and chat. So I'm creating a chat client with my model ID. So this is the deployment name that I put in. Now I'm connected to one model in Azure OpenAI that I deploy, in this case, is a GPT-4o. Okay? And so now I have the LLM, first part. So, and the 4o has reasoning. So the first of the 3, it's done. Next, I create as an AI client. So now I have the object. So I can use that object. And now I'm going to create 2 agents. One is with my same chat client, meaning I'm connecting to the same LLM. I could use multiple chat clients, one to a Llama and another one that's a multi-model, multi-agent system, but I'm not doing that. I name my agent and I give them the instruction set. Second thing that it needs, it's grounded now. Well, it's not very complex, the instruction set, but now each of them understands what's his mission. You are an expert in physics. You answer questions for physics perspective. And then you are an expert in chemistry. You answer questions from a chemistry perspective. So if I ask him about something, to explain me something in the world, like both of them will give me different answers, although they're using the same LLM, because of the instruction set, because of the grounding. So it's not that there's not a subtask here. They are just both of them collaborating to get the best answer, but each of them is grounded in an instruction set that is different from the others. So that's why the same endpoint will give me two different answers, because one has a mission, the other has another. So one has a perspective, another has another perspective. So when I use this, I basically go and through all the edges and collect all of my answers. I will get my final output will have two different perspectives, the chemists and the physics. Yes. Follow up? Yes, go for it.
Yes, thank you very much. And now for this one is calling both GPT 4.0. So we are spending 2 times, one in a role of a physician,
yes,
physics and chemist, but both are calling the same LLM, so spending the same amount of money. Only they are instructed to follow
different instruction sets.
Is that correct?
Correct. Yes, exactly it.
Thank
so
you
normally, when you're doing this, every time when you're doing agentic workflows, every time that you do a decision, you need to go through the thing. So there's let me see if I can. So this image helps understand this. So an agent, I don't show this much because I haven't updated. The symbol is still the semantic kernel, but the flow is the same. So an agent works in this loop, and could be like an almost infinite loop. So the way that it does is a user gets a prompt. So either a user or a system puts in the prompt, and now the semantic kernel in this case, or the math, will get that. It's already built into an agent. There's every configuration that you saw is already there. So now I'm interfacing with the user. I got it. I pick that up and I send it to an LLM. In this case, I'm using GPT. So I send it there, and this message came in. This is the context of the tools that you have. What should I do? This is what the framework does. Goes to the LLM, and what should I do? And the LLM will get to the framework in the structure of a plan. You need to run this tool, and then this tool. This is what you should do. Decompose the problem. So in this case, either the LLM knows the answer or knows the tool that should be called to get the answer. So then you do a function call on the agent side, on the code side. We'll call that function. And that function will return a result. And now you go back to the LLM with the result and say, this is the answer that I got from the tool. This is the output. This is the question. This is the plan. What should I do next? And then he says, now you call another tool, and another tool, and another tool. Eventually, either one of three things will happen. Normally you should configure a max number of loops so that you don't do an infinite loop. So after 10 loops, you end. You hit that. Or you get a termination. So basically the LLM says, I know the solution. This is the output for the user. And you build the output and returns that after going through the loop like 6 times or whatever, how many times it needed. Or it knows what it doesn't know. It knows, I hate the word knows. It understood that it needs to ask a question to the user, saying something very simple like, oh, to call the next tool, I need your ID number or whatever. And there's no way for me to get it, so you need to, there's one parameter I don't know. What is the answer for this question? And you answer, and now it goes into the loop with all the context, call the tool, and then gets the answer. So one of these three things happen, okay? Yes?
Yeah, can I jump in?
Go for it.
Completely different question.
Okay, fair.
So which is related with the fact that we have been witnessing a lot of new tools and frameworks showing up on the agentic AI field in the last few years. And even for the Microsoft Agent framework, as you mentioned, so it's built on top of 2 other frameworks from Microsoft,
Autogen and semantic kernel.
And semantic kernel. But at the same time, you mentioned that math is well, somewhat stable and and consolidated and robust in some sense. But from a university perspective. And you also mentioned that you have students in Lisbon, so I assume that you teach them these concepts as well.
Exactly.
So do you teach them Microsoft Agent Framework?
Yes.
And for how long will we have math before it is replaced by anything else?
That's a great question. Very hard to answer, to be honest. Honestly, because so the landscape is this, and this is a great question. So we started out with AutoGen. AutoGen wasn't enterprise grade, was from Microsoft Research, and was doing very good multi-agent workflows. Semantic kernel was very good at building agent, not multi-agent workflows. It was not as good. But it was enterprise grade. It was open source. It was everything that it needed to be, but could not replace AutoGen. And Sean becomes the PM of both. So they had two program managers. Sean becomes the PM of both. And then starts spanning out as the Foundry SDK for Azure AI Foundry was also starting to being built and everything. So Sean reached out to this, and then you have the M365 to build agent SDK was also being built. And then everything merged together. And so all of the products and everything in Microsoft started merging into what is now called Microsoft Agent Framework. So I don't think this is going to go away as fast as the other ones. The other ones we were experimenting. The lessons that we learned from building this all merged into the Agent Framework. So today, it's going to be harder for Microsoft to replace this because the product teams for Copilot, Xbox, even many of our internal tools are using math. So if we deprecate this, it's like you're going to hit yourself on the foot, on the 2 feet, and on all 10 fingers. Everybody's going to be starting crying. It's not going to be pretty inside Microsoft. So it's going to be hard for it to disappear, in my opinion. So that's my personal opinion, but there's always a surprise.
And by the way, if you could comment on other competitor solutions such as LangChain and LangGraph or Crew AI or any other kinds of solutions, which one do you think that is more stable or more apt to the challenge and worthwhile teaching about?
Okay. You're putting me on the spot. So, important disclaimer: I work for Microsoft. I have 2 GitHub T-shirts, and so disclaimers apart. I think all approaches are valid. Microsoft I cannot comment on other technologies and other providers' technologies, especially. But what I can say is, our solution, I think, both because it's open source, you can contribute to it. It's very stable. It's enterprise grade. You can use it on any LLM. It's completely open. There's no dependency on any of the Microsoft stack, not even .NET. Oh, I don't want to build it on .NET because I want to do it on Python. By the way, Python's creator now works for Microsoft. But still, the founder of Python is part of our open source community. We are the largest open source provider in the world, the largest contributor of open source, and commits more hours, paid hours, to open source. It's a different Microsoft from the one that I was used to when I joined, okay? Satya's Microsoft opened up a lot. In that sense, why would you not teach an enterprise-grade solution that is open source, follows all the principles, is stable, versus one that's not stable, questionably if it's really open or not, some of them, and it doesn't have the same level of banking. Okay,
let's make a softer question.
Thank you. Really on the spot here.
What is the learning curve of Microsoft Agent Framework as compared to other solutions?
Same or better, to be honest. It's way better documented, to be honest, in that sense. Documentation for this one is amazing. I can badmouth my own products as much as I want, so I'm going to say, a lot of products from Microsoft have really bad documentation. This isn't one of them. If you go online to Azure samples, if you go into the agent samples, Foundry, and there's so many out-of-the-box samples that you could create a class from. My repo that I was sharing, you guys can go on and can use it. I'm maintaining that repo. Okay, I'm building new. It works on. I was talking this morning about another framework called Aspire. So Aspire is like for microservice deployment, for serverless application deployment for dev. It's really, really cool. I'm putting all of my demos into Aspire as well. So you can deploy .NET, Python, CLI, command line interface, or Aspire in a microservice, all of these demos. So I myself am contributing a lot because I'm doing a lot of presentations on this, contributing a lot. Sean is working a lot to make the documentation as clear as possible. That thing is being updated every day. There's updates, changes, improvements, new samples every day. So, I'm building my repo will reference that repo. I'm building a one-day workshop from 0 to 400 of Microsoft Agent Framework, from observability to multi-agent, workflows, everything. So you could just pick that up. It's like 1 day, 8-hour workshop. It's going to be hard to do it in 8 hours. The plan that we have for 8 hours is like 16 hours, but we'll make it work. We'll make it work. People will develop faster. But we're building a lot of content. It's easy to pick up, but and it's very similar. The core concepts of all of these frameworks, no one is reinventing the wheel. It's not a new thing. It's like, oh, it's going to name everything different, because that would be dumb. It's name everything different, create new abstractions, and no one is doing that, fortunately. I hate that when it happens. So it's stable in terms of what the core concepts are for you to be indifferent to which path you're going. And in this case, I think you have a lot of help to build it for the students. For my students, I literally give them the samples and say, okay, I'm going through your samples, I'm explaining the code, I change it a little bit to make it a little bit easier, but then I say, the documentation is here. That's your goal. I'm not gonna give you slides or anything. Go to the latest version of the documentation, use that. And they go through it. They become independent. Honestly, that's the real world. That's what I do when the new framework comes out. Like, here's the documentation, solve it, and then it's done. So it's not hard. Really, it's not hard. You could, this morning, the students put their first agent to work in a matter of minutes. It took more time for them to create the subscription and build all of the dependencies than it took for them to put the first agent, the Joker agent creates jokes, to work. So it was really easy. Thank you for the question.
Okay, I think we already spent a bit more time than planned, and for sure there are some more interesting questions. But I suggest we could finish here. If you want to also talk with Marco, you could talk.
Oh, yeah.
But let's thanks Marco for his talk and this discussion.
Thank you, guys.
And thank you for coming here. So we hope we learned something. At least I learned, even in the morning, lots of things. I'm also trying things.
I'm really happy.
So thanks very much.
Anything that you need. So my handle is always the same, Marco N. Silva, either on LinkedIn, on GitHub. My email is a little bit different, but well, that's it. Reach out, feel free, and thank you so much for your time and for your questions. Thank you.